Hello, folks. My name is Dave Balbion. I'm actually the area dairy specialist in Central New York. So today's program is basically about integrated barn climate systems and the automation that's available to make these systems work without having to be messing around with them manually all the time. And I'll turn it over to Mark Reynolds from ASAP.
Hello, everyone. As he said, I'm Mark Reynolds. I'm with ASAP Interiors. ASAP Interiors is a large barn equipment dealer and distributor for the Northeast. We also do concrete. We try to offer everything that dairymen might need in the interior of a barn. I say if just about anything in the barn except for the barn. So my background, just to give you an idea, I started working on a dairy farm, a neighbor's farm, when I was 12 years old. When I got out of school, I started as a herdsman on a 100-cow dairy. And then we bottled our own milk, and I ended up taking over the whole thing. Was there for about 10 years or so. Then I got into the agribusiness sector. Selling equipment. I went to work for Norbco. Some of you have probably heard of that name, large barn equipment manufacturer. We were bought by GEA. I spent a total of 22 years. The last part of my career with GEA, the last 6 years or so, I did barn design, layout, and troubleshooting issues across North America. So I got tired of the flying, and ASAP came to me, and I went to work for them back in 17 and having fun running around New York. So we're going to talk about ventilation. You're talking about integrated barns climate systems. Basically, that is ventilation. Some automation helps, but when you integrate ventilation systems to create the climate that you want, it's a bunch of different things that all need to come together. So I wanted to cover everything. First of all, the concept of ventilation design, and then ventilation options, which entails barn designs and different ways to accomplish a good climate in the dairy facility, cow cooling, and overall integration. So, sometimes the answer is right there looking at you and you don't see it. So that's why I want to go through some of the stuff's a little simple that you probably already know. First of all, what is ventilation? The removal of contaminants and adding fresh air to increase oxygen levels. Ventilation options: you can naturally ventilate, forced air ventilation, tunnel ventilation, cross ventilation, which we're going to touch on briefly, and calf barn ventilation. It's always been a hot topic for me. I've spent a lot of years trying to fix, correct, create good ventilation systems for calf barns. And we've made a lot of mistakes through the years. My father told me, he said, if you're not doing anything wrong, you're not doing anything. He also said, you learn by your mistakes, so I should be a genius, I guess. So natural ventilation, air movement exchange without mechanical assistance. Basically, it's real simple. Warm air rises, cold air drops, air comes in the barn, it warms up, and then rises out the top in the winter. It's a very simple form of ventilation, and it ties in well to others. So, because we're in a cold climate, so our air inlets need to be controllable. Sidewall curtains are the biggest ability to ventilate. So we have a double roll up here. This happens to be a slider, so the top slides down and lets air into the top to control that ventilation. Sometimes the soffits are open, sometimes they're closed. I kind of prefer closing the soffit and using the curtain for the ventilation. Then you can control it depending on the temperatures. This is wide open for summer ventilation. It's a double roll up. Both curtains are rolled up out of the way, nice and neat. It works very well. Then we need the exhaust, and that's done with natural ventilation out of the ridge. You see the picture on the right shows an open ridge. We all know the issues with those. If you have them in your dairy barn, it's always wet in the drive-through. And the other problem with them is you can't control them in the winter. So if your soffits are open, you're going to have one cold barn. The one on the left is an overshot. That is controllable. You will get some snow and rain when the wind is not coming from the prevailing side, but as we try to face it away from that. But it has its challenges also. It works like a snow fence in some cases. I've seen snow pile up, and if it doesn't get taken care of, you will lose your barn. It's happened. I've seen some collapse. So what they recommend for the open ridge is about 2 inches of every 10 foot of barn width, if you choose to go that option. What's becoming very popular is the chimneys. This picture shows the chimneys. Some people call them cupolas, and in between are attic vents. You need some way to vent your attic if you have an insulated ceiling, otherwise it'll rain in there. It can be done with these or with fans drawing air out of there, and then we'll have ridge vent, some type of ridge vent that'll be drawing air from. But with this, you can control. So if you see this, the photographs on the left, you'll see the dampers, and they hook to a cable. They can be controlled manually or to a power drive unit, and that can be controlled with your whole house controller or whatever you're using. Now it's, I will tell you, I've had guys where I've put these in and they don't use them. So I'm not sure. I think some applications, maybe robot barn where you have to maintain a certain temperature may be more important than others. So advantages: winter ventilation for cows, limited capital investment, low operating costs, low maintenance, and it complements other ventilation systems, as we'll talk about. Disadvantages: relies completely on outside air movement. It doesn't work as well in high humidity when you have heavy air full of water. Cow cooling is in extreme heat, and it's very ineffective for cow cooling. Cannot guarantee air exchanges with natural ventilation at all. It's natural, and we haven't figured out how to control nature yet. Forced air ventilation, I call it this. Some people refer to it as circulation, stir fans, that type of thing. But when you lay it out correctly, you are forcing air from one end of the barn to the other. This will create a wind chill factor and aid in cooling the animals, as well as an air exchange. Forcing the air out of the barn will result in a guaranteed air exchange. Maybe not as positive as negative pressure, but it does move air. I've smoked a lot of barns, and when we smoke barns and the fans are set up correctly, you can see the smoke going right in and down the barn. So I know we're getting fresh air in these barns, and I've clocked up to 5 miles an hour on a calm day where there's no interference from the winds. So I know it does work. Complements a naturally ventilated freestyle barn. It allows easy transition from one to the other. These are the typical barn with forced air. We also use them in holding areas. Another option in a holding area, this is a new barn that was just built it's a parlor holding area. And it's hard to see in this picture, but we're sucking air from one side, negative pressure, and forcing in air from the other side. And this is kind of a new idea. Again, we've done similar stuff to this 20 years ago when we had these holding areas where we couldn't hang fans, low ceiling. So if now you could see the fans that are sucking on the right, the negative pressure fans, and the fans that are blowing air in on the left. It works. This is kind of a typical layout. I really prefer 8 rows of fans in a 6-row barn. Of course, I sell fans, but beyond that, I think it's the right thing to do, whether it fits into your budget and your power supply allows that. There's a lot of times issues with having enough power on your facility. Fan placement. We locate them over the feed alley. That improves comfort, dry matter intake at the feed alley. Essential with evaporative cooling. You have to have fans when you do evaporative cooling, soaking the cows. Fans located over the free stalls will improve stall comfort and increase usage. Oop, I missed one. Fans over the free stalls also improve water and increase water intake, comfort over the water. So this is another one showing the air coming in the sides, and that, like I said, will be drawing all the way down through the barn. Fan spacing will be determined by the fan diameter, fan type, and total CFM. It's also determined by mounting posts. So if your barn columns are 12 foot apart, you have a choice of either 36 feet or 48. Do not go to 48. We did a lot of those through the years. And again, we made a mistake. Will also have an effect on the fan spacing and the quantity, the post spacing. So airspeed should be around 6 miles an hour. It's very difficult to get that consistently throughout the barn, but it is kind of a target. And you notice these fans are pointing downward. We angle them so they blow just under the next fan. And at 40 feet, you will blow by the fan some, which helps with the dead spot that's created with the next fan. Thermostatic control options on this layout here. Basically, you're going to turn them off in rows or turn every other fan off. Not the greatest way, the greatest thing, because you have the full airspeed in 2 locations and no airspeed in another. So a better option would be variable frequency drives. And the biggest benefit I see is consistent airflow throughout the barn. So if you're running at 20% capacity, some of them out there only run down to 40. But even then, if you want to run fans and keep air fresh in these barns, you can do it and keep it consistent throughout. They're more efficient. There's a lot of grants. Depending on your power company and the fan. Some fans don't qualify, but today I think most all the manufacturers have got on board. You're not going to sell fans today if they're not efficient enough to qualify for these grants. There's some really good ones. And with the variable speed, they seem to be more generous. And then you get that consistent airflow that we talked about. These are a 52-inch fan. These work well. We can run them with a VFD controller as well. The other fan that's become more popular throughout is any direct drive fan. People are kind of tired of changing belts and pulleys or tensioners and that type of thing. Back when I started, that's all that was out was direct drives, the little 36-inch screamers. And everybody was sick of them, so we went to belt drives. Now we're going back the other way, but I think we've come a long way from there. We're able to do bigger fans and do a better job with them. This has a gear reducer on it, so you're not running full speed, so it's quieter. and more efficient. This is a control. I'm not going to get into all the details. You call me and we can talk about it if this interests you, but one box with 3-phase power will run about 80 fans. So you have one control controlling all of that. And this control can actually control soakers and curtains and so on as well. The other fan that's popular throughout different areas is 72 inch. They go up to 72 inch and they have louvers. They hang almost horizontal, kind of at an angle. They work very good for assist fans. And then then that's a permanent magnet variable speed and will run off a controller. Some of these require a control panel for every fan or two maybe. So it could be a little bit of extra wiring or a fair amount of extra wiring. So advantages: direct airflow on the cowl promotes cooling, guaranteed air exchange, allows for easy transition to natural ventilation. In the winter, you can shut the fans down or slow them down. I have some farms where we put variable speed in. They're running them all year. They'll run them at 20% in the winter to stir the air. So now it helps your natural ventilation by mixing the air and makes that air move quicker. Plus it helps limit the real cold spots because you're having more even consistent temperature throughout the barn. Less cost for construction and installation than some of the other options. Forced air disadvantages: I don't have too many. Is that there's a higher cost than natural ventilation, and to do it right, the upfront cost can be quite high. Negative pressure ventilation. So that is exhausting or removing air from an area to create positive air exchange. Tie stall barns, most of this is about free stalls, but I want to tell you, we saved a lot of tie stall barns with tunnel ventilation, negative pressure ventilation. The barns were so hard to ventilate. There wasn't enough ceiling height to put fans in. You have L shapes and H shape. With the tunnel ventilation, it works very well in most of those situations. If you don't have room for the fans, you open up a spot above them in the haymow. We've done a lot of different things to help dairies, tie stall dairies as well. Free stalls, they were real popular when I got into business with Norpco. They kind of went by the wayside. We converted a lot of them to forced air, and now tunnels coming back, and we'll talk a little more about that. We use them in utility rooms, negative pressure, parlors, holding areas. So basically, this is the pattern that you're going to see through the barn, drawn from one end to the other. Won't get into all the details on this, but what we do is we look at a cube of air that we're moving from one end of the barn to the other. So basically the height of the area and the width. And then we calculate that out and come up with the CFM that's going to take. You divide that by the CFM the fan puts out, and that tells you how many fans. Then we calculate what we need for inlet. So here's a barn. These are, you'll notice they have a cone on them. I highly recommend the cone. You can gain about 10% more capacity with the cone by adding that. And then on the inside, we'll do shutters, and then we can start and stop them. If you're not using variable speed, you can do them in banks. So, but you need to have the shutter to close that one down while you're running the start. You start with some fans and then gradually build your way up till they're all on at 65 degrees. This is the inlet end, where this is nice with an open curtain. If you lack for inlets, you can always crack the curtain. If you have roll-up curtains, you can crack the curtain along the outside row of free stalls on real extreme temperatures, and that helps. You have to be a little careful. You can short circuit the system and affect airflow if you open them too much. One of the biggest challenge is cow cooling with natural ventilation. I don't think anyone will argue it's the, or with, excuse me, with negative pressure ventilation. I think anyone will argue that it's probably the best way and the quickest way to do a good job with air exchange, but cooling cows, it really doesn't work well. We put baffles in and they were too high. We put this shows a picture of a curtain that we could roll down and roll them up when they come through with the feed truck, so we could get them lower. But in reality, the air is going above them and then coming down. And then it's going to go right back up. So you have all these dead spots in the barn where there's no air. And I've proven that with a chart and a flow meter many times. So challenges, undersizing air inlet, as we talked about, air intake, it's going to take the path of least resistance. So what's going to happen is it's like look at air like water. Okay. So when the water's coming down the stream, it hits a rock, it goes around it. If it finds an easier path, then we've got a tributary. It's going to go the easiest way. Air works the same way, especially negative pressure. So you'll see that drive-through will be, you'll have 5-6 miles an hour, step over where the cows are, and there's one if you're lucky. So that can be an issue in a standard tunnel barn. Open areas such as a connection to the parlor. Beyond that, on the intake end, that can drop, you'll actually drop a couple miles an hour off your airspeed because it's going to draw. If that's an easier draw and a closer draw, that's where the air is going to come from. It'll cool your connecting barn. Air quality issues at the exhaust end, you're going to have on longer barns. Shorter barns, if you're under 300-400 feet, it's not so bad. You start getting longer than that, then you start to have, you're accumulating contaminants and taking them down through the barn. So inadequate cow cooling, we just talked about. What we've done to fix that is assist fans. So we're back to forced air. You can put them further apart. You won't need as many fans. And it kind of works good together. You're getting good air exchange and you're getting air on the cows. But you always have to keep the curtains closed. So you're not taking advantage of the natural ventilation, but then in the winter you can. Variable speed is also available for any of the negative pressure fans as well. Why cross vent barns? Well, I'm not going to spend a lot of time on this. It hasn't become real popular out here. We do have some. The biggest popularity is out in the Midwest and the West, Texas, Minnesota, South Dakota is huge. And the reason is some of it's to maintain interior temperature year round, to control it, because they get extreme temperatures. It gets really hot and it also gets really cold. But I think the biggest thing is the benefit of the footprint. So these barns, they're building barns that hold 8,000 cows. It's crazy. And so I designed and laid out quite a few barns. Some of them didn't happen, but we laid them out. So a heifer at 21 days from calving will go in this barn and they don't leave until you sell them or beef them. So there's some benefits to that. Smaller footprint for a larger number of cows, and you eliminate all that trucking. If there's any of you that have heifer barns located somewhere else or dry cow facilities, you've got 2, 3 or more people moving cows all the time. Now you still have to move them, but you're walking them instead of loading them and unloading them. So if we can do effective air at the resting area and cool cows at the resting area with this concept, then I'll show you. And we talked about the footprint. So this is now when you put a baffle in, you're putting it over where the cows are living. So you can put them over the resting area and over the feed area. So when the air comes across, it's going to go high. It always does. I've smoked a bunch of these. It'll go up and it comes back down the curtain, but we'll clock 7-8 miles an hour on the cow at that freestall. So that does work. The other issue, again, as you get longer, you start to collect contaminants going towards the exhaust side. We remedied some of that because they didn't want to quit making them wider. So what we did was we put air tubes like you do in a calf barn and added big ones, and we added air. So you end up with a lot of expense with this as well. Now, I guess what a lot of them are doing, they're doing the assist fans, blowing air down on the cows instead of the baffles. So this is, I'm not going to get into a ton of details with this, it'll take too much time, but this is something we sell. There's a lot of different ones of these on the market. I don't want to mislead you, but this one is state of the art. It's runs your curtains, chimneys, air tubes, and it'll all run off a weather station. So if it's raining and the wind is blowing from the west, it'll shut your west curtain. And some of the simpler ones will do that, but this will also run soakers. It's quite a system, and it can be operated if you have internet in your barn. It can be operated with a tablet, smartphone, or a computer. Then there's a simpler way to do about the same thing. It's you just have different controllers running different things, and they tie together with thermostats. So they're all set to come on and do their job. Whether you want them at the same time or not depends on which system it's controlling, but it's all integrated. So either way, the Maximus is a lot simpler to operate once you get it running, I think, and then maybe this option. One thing I wanted to cover was cow cooling heat stress. It's a booger, and it'll cost you a lot of money, as you all know, in the summer. There's something they call the thermal neutral zone. It's a temperature in which a cow is the most comfortable and the most productive. And I put up 40 to 70. I hear that a lot. I've heard 35 to 65. When I start soakers or all the fans, I want it 60, 65, just to get a jump on it. Don't wait till it gets too warm. Then you have to cool them back down. So this is a good thing to shoot for. Now, you can also, as you all know, I'm sure if you're milking cows, you change your ration in the winter. Cold weather can be challenging as well, but nothing like warm weather. I think it's probably more manageable, at least from my opinion. What happens? Feed intake drops, milk production decreases, and reproduction a lot of times really takes a hit. I've had dairymen tell me, you know, we didn't lose too much milk, but I couldn't get a cow bred to save my life. And activity monitors don't work when there's no activity. So heat stress is a big deal. There's a lot of opportunity. If you don't have a good ventilation system and you're not cooling cows, there's certainly opportunity, and people are spending gobs of money to correct this. So how do we do it? Wind chill factor, as we talked about earlier, is very important. And then evaporative cooling. Now, this is a no-no. They're seeing soakers without a fan, but it's a really good picture of how the water jets onto the cows. So we want low pressure, 180 degree nozzles. We want large droplets. The way evaporative cooling works is, I explain to people, when you're in the swimming pool and it's 80 degrees out and you step out of the pool, you get a chill. That's evaporative cooling. The air is drying the water and it's taking the heat off your body. Works like our perspiration. So cows need help when they're all crowded in together, and this works. This, I've seen dramatic improvements in the summer with heat, milk loss, and feed intake with soakers. So the nozzles but it's very important that it's a large droplet. You need to get that through the hair and to the hide. We usually mount them, 6.5, 7 foot off the scrape alley, and then point them downwards at an angle, and you get a lot less overspray. So this picture, got this the other day just to make sure I showed the fans over it. Very important. If they don't cool as well without fans, you need to get that air on them to get them to dry. So you'll have 2 settings on your controller. One will be, of course, your temperature settings but one will be intervals. So that's how often it runs. And with the modern controllers, this will speed up based on temperature. So we'll have it soak more often. And then when the temperature goes down, it'll go the other way. Now this, then the other setting is soak time. That you calculate by looking at the cow to see if you want the water to come to the end of the ribs and not just sit on the back, and you don't want water running off the bottom. You're putting too much on. So that once you get that set, it's pretty much consistent. Evaporative cooling, extremely effective in preventing heat stress. Large droplets, as we talked, drying process, high speed over the cows, evaporate the water and remove the heat from the cow. It works, and it also works in high humidities. You can do this in Florida and some of these areas, and we get these dog day afternoons, I call them. This will still work. Very important in the holding area. That's an awful place to be when you're a cow. So anything we can do to make them more comfortable and start the cooling process. There is another option with fogging. It's going to be a bit of a challenge in a high humidity area like we're in up in the Northeast. What you're doing with fogging is, instead of cooling the cow, you're cooling the air. So we put high pressure nozzles, high pressure pump, and we're making a mist. The air picks this up, and when the air picks, it's very important to have airspeed. When the air picks this up, then it's going to cool the air. The problem is, if you have a lot of water in your air in a high humidity area, then it's just not going to be able to take it in. It's not going to work. So bunching, this is a big subject here. So it's cows that are congregating in one area to avoid an undesirable area in the other part of the pre-stall. Very negative effect on resting time, feeding, water intake, because they're all grouped together, standing there in a bunch. I'd be surprised if there's anybody on here that milks cows that hasn't seen some of this. Possible. So reasons: sunlight and heat, barn orientation, flies, and inconsistent ventilation. Solutions: shade cloths have worked some, and it depends on the orientation. If it's a north-south barn, shade cloths on the sidewalls are going to help. East-west, you're probably going to have cows leaving the ends of the barn when the sun comes over. So some guys shut the doors. Biggest thing, though, in my mind, is flies. I've spent a lot of time on dairies trying to help dairymen figure this out. And fly control is one way. Consistent ventilation is getting more air. The more air you're moving, the flies don't like airspeed. So if I can help with this, track me down and I'd be glad to come out and take a look at your barn. Get short on time. So calf barns, hutches still work, and there's still a lot of guys working with hutches. I think the problem is they're being able to manage them in the cold weather and do a good job catching cows with certain problems. So this is a calf barn here. We're doing these narrower calf barns now, and we're going to talk more about them. But in my mind, there's 3 stages of calf barn ventilation: winter ventilation, of course, cold weather; summer ventilation, hot weather; spring and fall ventilation, which I call transition weather, although I had 16 below zero Saturday morning and Sunday afternoon was 45, 50. So that dramatic temperature change, and how do we deal with that? So we have, so for cold weather, we're looking at 15-minute air exchanges, limited draft on the cows, mechanical exchange, air exchange is imperative. So that's important. Calves don't generate enough heat to create natural ventilation. Natural ventilation does not work well in a calf barn. Natural ventilation does not work well in a calf barn. We need to mechanically ventilate. Now I'm going to back up a little bit, because I do have a few barns where they're either in front of a lake or something, and there's wind blowing across through the barn, orientated correctly. It can work, okay, but the calves aren't going to do it on their own. Mechanical inlets, curtains, and pressure tubes getting fresh air in throughout the year. So this is a winter ventilation here in this barn. Curtains are closed. And then this is a double roll up. So we're actually rolling the top one up, which in years past, we never thought we could do that. But you make a smaller curtain up there, it actually works really well. The cold air coming in is going to drop. You're not going to stop it. But the main thing is that you don't have air blowing directly on them. The chimney fans, we're showing the right is the chimney, the left is the fan connected to it underneath. I really like an insulated ceiling in a calf barn, but we've done some without it, and they make them work as well. A lot of it depends on the size of the barn, I think. These are variable speed fans. And then we can also shut every other one off when it gets really cold. So this is showing the air tubes. This is that same barn that we had the outside picture of. And there's 3 tubes. Tim Terry helped with the design of this. I got him involved in this, so we got the tubes correct. And it's working extremely well through the winter. We haven't been through a summer yet, but through the winter. So we have a large tube over the 2 pens together, and then a smaller tube over each outside. So there's 4 rows of calves in this barn. This just shows a picture of where the tube hooks on the end. We have a hood to protect the fan, simple fan, same fan that we use in the chimneys, actually the same brand. Summer ventilation, hot weather, we're going to need mechanical ventilation to cool cows. Unless we have an abundance of wind, consistent airflow through the barn. Maximum air inlet, so the curtains are wide open. You can leave the positive pressure tubes running and leave the exhaust fans in the chimneys run as well. Then, what happened to my transition slide? So, the transition portion of that, so the going back and forth spring and fall, it's basically a combination of the winter and summer. So it's a matter of being able to switch back and forth. And this is extremely important that it's automated. It just doesn't work well manual. There's probably a farm somewhere that has the ability to open the curtains and shut them the same day, and open and close them and make sure the fans are running, and then you shut them off. And automation is the right way to do your transition weather in this situation. Sorry about that slide, it disappeared. This is showing another barn. Now this is an insulated roof more than an insulated ceiling in this barn, but this has this fella built back up. There's 3 barns here that he built, and he's probably going to do another 3 or 4. And so we have chimneys, and we control them with the Maximus controller. Chimneys with power vents, and these actually have dampers in them. So when you shut a fan off, the damper shuts. And he has overhead ceiling fans, which he runs in the summer. And we're finding that works pretty well. get some better pictures of it here. In this barn, this is two barns side by side, and they have a connection between the two. Again, chimney fans, and we're doing the ceiling fans here as well, automated curtains, everything is linked together. There's your chimney fans. What's nice with these is they're variable speed as well. They're bi-directional. The first farm I showed you, he tried reversing them and didn't really see a good response to that. This dairyman was going to experiment with it this winter. I thought maybe in the winter we could use that to circulate air without blowing air on the calves, causing a draft. There it is. This is the slide that I was looking for. So we already went over this. This transition weather is one of the things that hurts dairies more than anything else. So it hurts the calf barns. It's very challenging. So like I said, automation is very important. And we have the same systems we can run the calf barns with. This is the same. The second barn I showed you is using this type of system. This is actually a picture from that barn, and they're having very good luck with that. Why automation is important? Well, this might ring home to some of you. So I wanted to thank you all. I know I kind of went through it pretty fast, but I'm available. If anything I can do to help you on the farm, come and visit. You're more than welcome to call me. And okay, so here, I think you're ready.
Okay, this is Dave Balbion again. Thank you very, very much, Mark, for all the information that you provided to us. There's a lot of these topics you could talk for an entire day about them. So anyway, appreciate it very much. And again, I want to thank all of our sponsors. This is the last in a series. They've all been recorded, including this one. And it's going to be available on the ProDairy website on February 28th. Kind of an interesting thing before we open it up for questions is that, Mark, you had mentioned about learning from mistakes. I can think of he's an old timer now, but a very successful dairy producer. He never went to college to get a formal education, but he was a smart guy. And I remember him telling me, he said this a couple of times. I worked with him quite a bit over the years. And he said to me when he made a mistake and it cost him some money, whether it was lost income or an expense that wasn't necessary, he said, well, I guess that was tuition. So anyway, I asked him one time, I says, what do you mean tuition? He says, well, I never went to any of these fancy colleges and stuff. And he said, I learned from doing things. And when I make a mistake and it costs me some money, he said, I guess that's my tuition, because I didn't have to pay tuition, but my tuition was basically kind of the school of hard knocks. So anyway, we'll take some questions here. At this point, Caitlin, are you able to access the questions, the Q&A?
Yep, we're all set, Dave.
Okay, so let's go ahead and go ahead with the first question.
Okay, so just a reminder to everyone, if you have questions that you're thinking about, just go ahead and pop them in the Q&A box. We do have a couple of questions to get you started, Mark. And the first one is, can you review those air speeds that you went over, specifically over the cow and at the fan level during cow cooling? And specifically, this question is about fans and mist, but maybe you could just review the fan speeds first.
Sure. Can they hear me okay from here?
Can everybody hear him?
Well,
Yep, we can hear him. Yep.
Oh, okay, great. Okay, I'm in front of the camera here, so but he's off.
Okay.
But,
So good question. So 6 miles an hour would be that I mentioned on there would be a minimum on the cow. So you realize that the air coming out of the fan is going to be, to accomplish that, I've seen gusts up to 18 you know, but generally it's going to be about 10, 12 miles an hour when it comes out of the fan. And then it diminishes as you push across. So spacing is very important to make sure that we maintain that airspeed that we really like 6 miles an hour on the cow to help cool that and get that heat off from them. So I don't know if that answers your question. But to maintain that throughout the barn, it would take a lot of fans. So that's why we focus on over the feed curb, over the feed lane where they're eating, over the free stalls, and all the free stalls. If you have enough power and you can afford it, it's really the best way to get that full column of air going through the barn. I spent a lot of time with the flow meter in the barn. And one thing I will mention, some fans are better than others at consistency. I was in a big dairy out here in New York, and I went through every one of their barns and I measured under the fan to see where we started. Then I measured in the middle and the next fan and documented it. And it was an eye opener with some of the 3-blade fans. I was seeing a lot of gust, and all fans gust a little. What I mean by gust is it'll raise and the speed will go up and down. Standing in one spot, it just goes up and down. 6-blade fans seem to be more consistent. And we sell all of them. So I'm just saying it just seemed that way. But you're going to get gust. So when I say 6 miles an hour, it may drop to 2 and then back up to 6. It's going to vary some. I have yet to see a fan that's 100% consistent standing in the same spot.
That's a great point, Mark. Thank you for that answer. Now we have them rolling in quickly. So let's see what if I can get some of these grouped together. So again, talking about a little bit about mist, what is the most suitable humidity inside the barn? And is there a way to control the mist volume versus the relative humidity in the barn like you had talked about?
So it sounds like they're talking about the misting, the evaporative cooling with the air. Is that correct?
I mean, asking about
fogging.
the fogging.
I think, yes.
Yeah, about like, I think this was the same question from someone about fans with misters. So I'm not sure if this question
Right.
specifically about mist.
Yeah, and that's okay if you're misting on a fan, as long as it's not high pressure, and some of them are, but it'll cool cows immediately in front of the fan. There's some guys that like them and have put those in with the misters right on the fan, but it's not true. You're not cooling the air with those. It takes, what's it, like 1500 PSI or something like that. It's in tiny nozzles to create that mist, that fog, so that it'll go into the air. And as far as controlling humidity, I don't have a way to do that. And the best humidity is none.
Yeah.
But it's acceptable levels. I don't know, 40%, 30% humidity, maybe. Once you get up into that higher, above 50%, that's when it really starts affecting cows and how they eat and milk production.
It's just about impossible to really control that humidity. I mean, I've had some people with tie stall barns with tunnel ventilation ask me about that, and I can think of one case where basically they were short of capacity on the fans. Anyway, they were in a neighbor's barn. They said it's much better in our neighbor's barn. Why is that? Well, we figured that out, but when it got up to like 95 degrees with nearly 100% humidity, they're like, wow, it's still pretty warm. And I'm like, well, you're not going to change the outside air temperature. The temperature is going to be what it is. You're just counting on moving that air past these animals.
Wind chill does
of that wind chill. Yeah.
Wind chill does help.
But
it helps a lot.
the outside air is what it is. You can't change that. Yeah.
Well,
So,
you can, if you want to spend a lot of money,
Well-
you can put cooling pads in and run
Yeah.
more like air conditioning, but that doesn't work either. So
Yeah.
Dave's right. There really isn't much you can do about
Yeah.
it.
Yeah, I've heard maybe it's in Saudi Arabia, if anyone's on, they can correct me. Like some air conditioned barns, but I have not seen that myself.
I don't think the economics,
I struggle getting them to buy fans.
yeah, I
in
think
some
the
cases.
economics of milk production in the States does not afford us to put
No.
air conditioning in. Absolutely. We could air condition the office where people are.
Yeah, if we're lucky.
Sounds like
All
we
right.
need more.
So,
Yeah.
next question, what is the correct direction, of shades over a feed lane? What's the correct orientation?
Correction, the direction of the fan.
No.
For shade cloths over a
shade
feed
cloths?
lane, yeah, I'm assuming it's an out,
That goes outside.
yeah,
On the outside wall, and like I said in the presentation, it depends on your barn orientation as to how valuable it is. But we've had some real success with the shade cloth. You'll see guys hang them from, I don't know if this was what they were looking for, but you go out on the overhang, hang them from the overhang. Some people just let them swing in the wind. Others will pull them down and fasten them. I've seen 2x4s and pipe coming down, and it'll lay on that. And then you put a pipe in the bottom of the shade cloth and weight it.
Yeah, okay.
And-
Hold it in
And
place.
sometimes they put them up right up against, open the curtains, put them up against the curtains, and then take them down in the winter.
Yeah.
There's really isn't a great way to do it, but I can't stress enough on shade cloths. Just keep in mind, the more sun you block, the more air you block. So you got to find kind of a happy medium there.
But it's,
We really don't want to block the air and natural.
but they're kind of specific to the situation, the barn, everything is kind of unique
Yeah.
to each facility, right? Yeah.
Correct.
yeah, this participant was specifically asking, the direction in relation to sunrise, so they had east-west, fa-
Oh,
oriented feed
orientation of the
lane.
barn? Orientation of the barn would be east-west. Is what we've always recommended.
Okay,
So, but then you'll have problems on the end of the barn. You know, because you'll get sun coming in, and like I said, you can put doors on the ends of the barn. Or shut the doors on the ends of the barn. Some guys have had some luck with that. But sometimes you have to put them north and south. It's we can't always decide that. It depends on the site.
Right.
And how grandpa started the whole situation where he put the first barns,
Right.
you know. Sometimes it's just out of your hands.
Yeah.
And that's where the shade cloths help.
next, what is the optimal airspeed and soaking frequency in the holding area?
Actually, you know, we talked about the 6. I'd like to see more. I put fans closer together. The more air, the better blowing on those cows. It's just like I said, it's a terrible place to be. And when it's 80 degrees and high humidity on top of it. We generally just soak them constantly in there. And then and that's pretty much all the time. When they come into the parlor area, it's nice if you have air flow in there. It's sometimes a little more challenging to get air in a parlor. I've done that with cross ventilation, blowing air. Actually, I blew air through a barn, through a parlor on one side, blowing out the other side, and they had to shut them down because the teat tip was blowing across to the other cow. We had too much air, but yeah, I think I answered that, hopefully.
It's not a specific number, really. It's
No.
just kind of the situation. Yeah.
Okay, so unlike in a barn where you kind of saying 6 miles per hour at the cow, there's not a number specifically.
I
in the
would say
area, just-
12. If you could get 10 or 12 miles an hour would be best. If you're
Yeah.
looking for a number, that's gonna be putting the fans awful close together. But I
Okay.
generally would do that in a holding area. I would put them closer together. Sometimes, like I showed that picture, we blow air in. I done a barn over in Connecticut, and we put fans on both sides of the holding area blowing to the center. And they're real happy with that. We've got some tremendous airspeed on the cow. It's a small holding area, narrow. So it worked really well.
But I think of these cows, every one of them is a little furnace. And you pack them all together in that holding area when it's 90 degrees out, and you can understand the situation
That's
you're
a
dealing with.
bad environment at
Yeah.
a holding area. That's why we talk about having smaller groups and moving them through, getting them through in less than an hour. That's one of the big reasons for that.
Yeah.
Sizing your parlor correctly is a big deal.
Yeah, yeah, great other things to think about as well. Thank you. Okay, next question. Are any of the farms you work with using the data from some of the environmental systems that you mentioned for decision support? And if so, how are they? And how do you promote data capture and storage from those systems?
Well, I would like to, I hope they do. I know we're in a sheep barn and we a big sheep farm with the Maximus. And they monitor that data regularly. I'm not sure about capture. I think that could be routed to a PC. I haven't done that. But yeah, it's a great tool. Sometimes we went through this with robotics and stuff too. People just don't take advantage of it. It's there. So as far as the information, when you have a problem, that's what's nice. When something goes wrong and you have that documentation, you can look and see what happened. And that's what this, the dairymen cows especially, they're not as, don't seem to be watching that quite as close as someone like a sheep farm or calf barns is where it's really critical.
Yeah. Yeah.
You start having respiratory issues, what went wrong, what were we doing when that happened? And you can go in, they all have memory, you can go into that, well, the Maximus does, you can go into the Maximus and see what happened.
Yeah, that's one excellent invention. I think I heard once that you'd have to change curtains like 40 times a minute to keep up with all of the changes 40 times an hour or something like that, to keep up with all the environmental changes that we see in our area anyway. So pretty handy.
And you can automate fairly reasonable. You don't have to buy the Maximus. You don't have to spend gobs of money to automate. For what the return on automation will pay for it in a very short time, I think. Unless you have a lot of help and you're able to do a good job manually. And that can happen.
But rarely, probably. As far as doing it. Yeah. Yeah.
I'm sure there are people that do that. Smaller dairies, it's easier probably.
Going back to water, so feed line soakers. What do you recommend for the interval of soaking, or do you ever recommend continuous flow?
I don't recommend continuous flow at all. You need to dry. Drying is the most important part of soaking. We do it in the holding area, but keep in mind they're moving through. And we have a system in the holding area where we can turn them on and off, but it's not practical. We just run them through. But on the feed line, it's important to give them that dry time. So intervals are, of course, depend on your zones, okay, and the number of zones. Usually I try to stay in the 4 zones. And so because you only run a zone at a time. So you're going to have some limitations, but usually in most cases you can do it, every half hour, 15 minutes to a half an hour, let's say, in intervals, and then it'll come back around. So you're going to soak this quadrant, this will shut off, soak the next one, the next zone, that'll shut off, and then they're all drying while you get to the next one. And finally, when we get through the 4th one, then we'll go back and do it again. And in temperature too. That's why we have that setting. It's called the smart sensor. It'll slow it down when it cools off and speed it up. Do it more often when it gets warmer.
Okay, great. Just a question that I have actually regarding the soaker systems while we're on the topic. Jeff Bewley had talked to us a few weeks ago about some of the feed line soakers that have a sensor, like a motion sensor. Have you installed any of those systems, or have you seen farms using those for water savings?
I have not been on a farm that's using them. I was at World Dairy. That was the first I'd seen them in a couple displays. I can sell them. I have the option. I'm not sure I'm 100% sold yet. There's certainly some merit to it. If I can see in an area where you're lacking water, and that was something I probably didn't touch on. One of the challenges with soaking is, do you have enough water,
Right.
and do you have enough lagoon space for all that water? Okay, now keep in mind, if it's done correctly, we have our intervals and we set the soak time correctly, a lot of it should be evaporated, but it won't all be evaporated. You're gonna have extra water when you're soaking cows in your lagoon.
But
So I think they're onto something. I don't know how well they work yet. I'm not saying they don't. I just don't know. It's new.
But it's getting at a situation where if there's no cows, if everybody's laying down and there's no cows there, what are you soaking? Just the
Well,
floor, basically,
That's what
right?
you
Yeah.
saved, and
Yeah.
we have the ability to shut a zone off when they take them to the parlor. The problem with that is they don't turn them back on. It's
Yeah,
a
yeah,
manual
right.
feature.
Yeah,
You
okay.
know, and
Yeah.
trying to calculate when to do that automatically is somewhat difficult.
Right.
Yeah,
yeah.
great considerations.
That's a good question too.
Hmm.
But
Yeah, I know we're often talking about water usage and tight on lagoon space, so I was just curious.
I'm excited about it. I'd like to go see where it's working. When I figured the cost out, it's more.
Yeah,
And there's a few challenges. You want to make sure that sucker's up in the air because cows like to eat nozzles,
yeah,
but they're fairly inexpensive. These are not.
yeah.
So,
Yeah.
But I see some advantages to that.
No, well, stay tuned, I guess.
Yeah.
Have you ever seen issues with stray voltage when using variable speed equipment?
Well, yeah, so, but there's stray voltage on farms, probably it's caused by something else. Okay, and this is what the guy that designed the variable speed control that I showed. He said that if they've got stray voltage, it can't be coming from this system. Okay, the way his system is designed. Now, there's a lot of different variable speed with these PM motors and stuff. All that needs to be wired by a certified electrician that understands this and does it with code. I guess the answer is it could be. It can be caused if not wired correctly and set up correctly. And I think there's a lot of things that I know in Wisconsin, when I started selling out there, you couldn't use any 110, not even for heaters and water or anything. Everything had to be 220 because 110 with that neutral is more susceptible to having stray voltage.
Or 220, you automatically have a balanced load with that kind of a system,
Yeah,
which
you
reduces
don't
the
have
risk.
that mysterious wire coming back that actually has some power on it.
Yeah.
People hook
Wow.
them to the ground and
Yeah,
that neutral. So, yeah, I'm not an electrician, so that's a big topic, but I would say anything's possible if it's not wired.
so have
correctly.
a certified electrician, a real professional.
I'm surprised I haven't had a noise question. The biggest thing with VFDs were noise, but we've corrected a lot of that with filters. There's things you have to make sure you do. I'm not going to go through all that now, how you run your wires. I had a case with noise that was affecting from our VFD that was affecting their portal ID system coming into the parlor, and they had run the wire right over the top of the portal ID. So there's things that you can't do that are things you can do to prevent some of this. You don't run the wires with something else. in this system has a filter system to filter out the noise.
Hmm.
But noise, in case there's people listening and don't understand what that is, that's just that's going to interfere with your ID system, can interfere with your activity, all that,
Wi-Fi, maybe. too?
Wi-Fi,
Yeah,
anything.
yeah.
So,
Gotcha. The take home from that is, sounds like hire a good electrician.
absolutely.
Okay, switching gears a little bit. So, a question here is, do you find much interest on dairy farms to include sensors in multiple locations in the barn? For example, integrating air quality, air speed, air temperature, that would be able to send data back to a computer and automatically change mechanical devices. So kind of an integrated system.
Yeah, that would be, I could see some merit to that. We do with this VFD system we sell, we do use an anemometer in the barn, which will pick up airspeed in the barn. As far as having that throughout the barn, no, we haven't done that yet. We do try to do more temp sensors. So we have a more accurate depiction of what what we need to do, what the temperature is and what we need to do to change that. Haven't gotten that scientific yet with setting a barn up. Maybe Cornell could help us with that. But
Sounds like a fun idea.
it would be, it would be interesting but it could be done because you can control fans individually. And I mean, it could be done. My theory's always been put enough in and just blow the heck out of the barn when it's hot. And when it's cold, you slow them down and just keep the air moving and rely on natural ventilation. But it would be interesting.
A lot of these things are possible. I've had lots of people ask me about, do we remodel this barn? Do we build a new one? Or can we do this or that? And I always tell them, you know what? Anything is possible. The real question comes down to, is it really worth doing when you think about the investment? You can overcome a lot of things by spending a lot of money to change things. In some cases, it's not worth it. You go to some other option, maybe even a new facility, but anyway.
Sure. Well, talking about facility, in a barn that has that houses cows and calves within the same roof. If you want to divide airflow areas, do you need a hard wall or will a soft wall work to divide airflow areas? Or are there other suggestions?
I don't know what you mean by
Can
a
you-
soft or a hard wall. I don't know what that.
I would imagine they're
Isn't that about
talking
the
about
cap
like
then?
a sheet, what are they called? Like a vinyl sheeting or something like that, like you make the baffles from, like would,
Oh, to
I'm
divide the
assuming I'm
calves
reading into
from
the
the
question.
Yeah.
calves from the cows. I've done a few of those and Dave saw me, I cringed.
There's a little bit of a sigh when you read that question, calves and cows in the same building, because the requirements are different,
Yep,
really.
two
Yeah.
different ventilation systems. What we did in the one, and the last I knew it was still working. They had heifers, bred heifers, dry cows, and calves over in one quarter of the barn, and they had a warm room. When they did the warm room, they bought in-floor heat for that and never got put in. So they were having a lot of trouble with calves. We took that heat and they hadn't poured the concrete in the pens yet. So we put the heat under the calves to get that air to move out of the calf pens. And there's actually a big dairy in Wisconsin that does that on all their calves. They heat underneath, and that creates warm air rises, and that gets that nasty air away from them quick.
Of course, it helps
But-
to dry the floor too.
But
right?
as far as I know
Yeah.
what they're going for now with that barrier, as far as, so you're trying to blow air and cool cows, which they do best if down to 40 degrees, right? If we believe in the thermal neutral zone, which I do. So you don't want that draft on those calves. So it's a different it's difficult, and I wish them luck if they're doing that. But then maybe we can figure out if you can get some heat in those pens so they get natural ventilation, whatever you're doing around them. But it may be impossible with what they're doing.
Not ideal. Yeah.
Yeah, and maybe since all barns are so different, maybe that person could reach out to you directly with their barn design.
Please do.
We are on to the last question. Thanks for sticking with us for a little bit longer here, Mark. What is the best droplet size in soaker systems for evaporative cooling? I remember you said large droplets. Is there anything more specific?
I don't know. I've never measured a droplet.
But
What size
But
it
it's
is.
related to the nozzles size,
It
right?
is, yeah. I could probably come up with that.
Off the top of your head, do you know the nozzle?
Don't.
Okay.
But it's the biggest thing along with that is not just the nozzle size, it's the pressure. So
Yeah.
on our systems, we actually put a pressure reducer. So we want that under 35 PSI.
Oh, okay.
So whatever nozzle you put in, if the pressure is too high, you're gonna have a finer
Yeah.
droplet.
Yeah.
I can get that information. I can't remember the opening on that nozzle, but that's what's gonna control that, and the pressure together will control the size of the droplet. And I can tell you what nozzle you need and what pressure you need. To tell you what the size of the droplet is, I'd be guessing.
Yeah. Okay.
Yeah, well, those sound like the best things to look for anyway, when you're putting in that installation. So thank you very much, Mark. We really appreciate you answering all those questions, and I will hand it back over to Dave.
I guess with that, I just want to say thank you to everyone. Thanks to our sponsors. Thank you again, Mark, for all the time you spent putting this all together for us. And so thank you for participating. We appreciate it very much.